All right, this next one is poker specific. I'm just doing it mainly as a demonstration purposes because, again, you might not be familiar with the terminology, but just so you learn that you should never, ever gamble is the point of this problem. Okay, so in the game of poker, you get 5 cards in your hand. Now you might ask, well, what if there's other people playing? How does that affect things? Mathematically, it doesn't because it's random the way you get your cards. So whether there's 20 other people playing, well, you can't have 20. Whether there's 4 other people playing or 1 other person playing, these probabilities don't change. Now, we can only do the probabilities from when you initially get your hand. Anytime after that where you're swapping out cards, yada, yada, all these formulas are gone because then it gets way too complicated. That's why you wear the dark sunglasses and to hide your tears, right? Yeah, that's what. See, if I ever did that, I would wear clown makeup because I think that'd be disturbing. Right? Hello. Yeah. That'd be great. All right. Part A, how many 5-card hands are there? Well, this is a counting question. There's no probability does not appear. It's a counting problem. So this is a 2, 1 through 2, 3. Where does this fit? In what section? 2.1 would be really hard. Well, 2.2 implies permutation, where you have distinct objects, which we do. All of the cards are different, but does order matter? No. The way you rearrange the cards in your hand, it's still the same hand. So we have distinct objects, but order does not matter, so this is a combination of how many total cards and how many are we choosing? Good. So there's a combination of 52 cards, taken 5 at a time. So again, for work, if you wrote that, if you wrote 52 NCR 5, that's cool. But I need one of those 2 things, and then I need the number. This is a big number. So if you've ever played cards before, this high of a number should not surprise you because it's really hard to get certain arrangements of cards. Good. Now notice part B. So again, these are technical. I doubt I'm going to ask you a poker question on a test, just in case they come up in the homework. They are still good exercises because cards come up a lot in stats. What is the probability of a flush? And as it says there, a flush is 5 cards of the same suit. So let's talk numerator and denominator. The numerator would represent what? Careful. Numerator is the part. The number of ways to, so a number of ways of getting a flush. Denominator represents number of ways of getting your 5-card hand. So the denominator is done. That's part A. That's that 2 million number. So again, the numerator represents the number of ways of getting a flush. Denominator represents the number of ways of getting 5 cards. All right. Here comes the numerator. Everyone got a boots on? It's going to get deep. Uh-oh. All right. We'll hose you off later on. All right. Number of ways of getting 5 cards of the same suit. How many cards are in each suit? 13. And if we want a flush, how many of those do we want? 5. So of the 13 cards, we want to pick 5. But, added bonus, we could get a heart flush, a spade flush, a club flush, a diamond flush. So we need to multiply this by 4. But that could also be thought of as a combination you can say, of the 4 suits, we need to pick one. 4 combination 1 is 4. So let's go over the numerator one more time. The 13 choose 5 means of the 13 cards in one particular suit, we need to pick 5 of them. The 4 represents of the 4 suits, we need to pick 1 suit. Okay. So in your calculator, you'll do 13 choose 5 times 4 choose 1. I just read part C, that's fine. What is the numerator 13 choose 5 times 4 choose 1? Yep. This does reduce. Your calculator may not be able to reduce it. After a certain while, if the denominator is too big, it says, I don't know what you're talking about. You get 33 over 16, 660. Now, if you look in a book that shows or displays the probabilities associated with flush, that is not the answer you'll get, because there's a very, 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 very good type of flush you can get. Does anyone know what it's called? A royal flush. That means it's 10, jack, queen, king, ace of any particular suit. So if you're in Vegas and you have a royal flush, that's everything you have. Absolutely everything you have. Why? Because how many ways can you get a royal flush? 4 out of 2 million some possibilities. It is the best possible hand. So like literally, any jewelry you have, put it on there. If you have children, put them on the table. Bet it all. Worst case, you never have to worry about babysitting again. So please, there you go. Thank me later. I'll take 10%. All right. So in other books, it would actually say 5144 because they took out the 4 of the royal flush. So this actually includes the royal flush. Way too technical. We're not going to get into that. All right. C, probability of a full house. As it says, a full house is 3 cards of one value and 2 cards of another. So if you had 3 queens and 2 jacks, that's a full house. So since it says probability part over whole, what's the whole going to be? That 2 million number. Let's think about how we're going to break down this numerator. So we want to get 3 cards of one value and then 2 cards of another value. How many cards share the same value? So like how many jacks are there? 4. So I think I gave the example of what, 3 queens and 2 jacks? So let's use that. So out of the 4 queens, we would want to pick 3 of them. So combination of out of the 4 of the first value, we want to pick 3 of them. And now we have to pick a different value. 4 of 2, because we want 3 of one, 2 of the other. So a combination of 4, 2. But there's actually a hidden bonus here. How many values are there in a deck of cards? Values. Mm-hmm. So 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, ace. 13. Out of those values, how many do we need? 2. So this is the third combination. My head hurts. I know. So there's 13 values, 2 up to ace. 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, queen, king, ace. That's 13 values. Is that okay? So every suit has 13 cards. And since we need to make a full house, we need 2 values of those 13. What do you get for the product in the numerator? Thank you. All right, and then if you did reduce, which again your calculator may not be able to, you get 3 over 4165. So again, a horrible set of problems. I'll be very honest. The chances of me putting one of these on the test, very slim. Part A is okay. That's a decent question because that's just straight up combination. But B and C are a little icky sticky. Now we only focused on full house and flush. You have different other things. You have straights. You have pairs, 3 of a kind, 4 of a kind. Those are horrible. So we're not even going to talk about them. If you're morbidly curious, feel free to just do probabilities of poker hands on the Google and then wear the sunglasses because you will cry.